Hello everybody, welcome back. Today we're looking at 7.8 example number 3 toward the end of the chapter. It says synchronized divers perform matching dives from opposite ends of the platform, that is 10 meters high. If the two divers reach the maximum height of 0.6 meters above the platform after 0.35 seconds, how long does it take them to reach the water? So we'll draw a little diagram for that. And there's our diagram. Alright. Remember, we always define our variables when we can. So we let t, remember t is time. That goes along the x-axis, or the horizontal axis, it's independent. So we're going to let t represent the time in seconds, right? Okay. So this is on the, for us, most of us know this as the x-axis, okay? And it's horizontal, as a reminder, right? Okay. I guess I'll say or horizontal. All right. So that means that down here we call it time in seconds, right? That's how you would label your diagram. Oh, it's time in seconds. Okay. And horizontally, what we'll do is we'll let h of t, okay, you can just call it y if you want. This is the fancy notation. H of t is function notation, notation. All right. And that is going to represent the height in, and it said meters. That lower m represents meters. Oh, sorry. And that's the y-axis or the vertical. Okay. The vertical axis. And then we'll sketch the curve. Always sketch a diagram, and that's what I did already for you at the beginning. Right? And it said the platform is 10 high, so at 0 seconds it's 10. They jumps up 0.6 meters, so we add the 0.6 to the 10 to get 10.6 for the vertex, and that happens at a time of 0.35 seconds, and then they go down to the water. How long did it take them to reach the water? So we're looking for the t-intercept, which is essentially the x-intercept right here. Okay? So first thing we know, we're going to need to find the equation. So we've learned 3 equations up to this point. All right. Now, if we have the equation in vertex form, I'd recommend using vertex form. We have the vertex, right? So that's the easiest to use. So we go get that formula. So we find the equation. There's the equation in vertex form. H and K in your vertex form of the equation is right here. 0.35 and 10.6. So that's the vertex. Then you can pick any other point, x and y, right? So pick any other point. And obviously we clearly have, and that'll represent x and y, or you could use time and ht, whatever you wish. And that x and y, I'll pick the y-intercept. I usually pick the y-intercept if it's available. Okay. Again, only if it's available. And we know it's 0 and 10. Oh, sorry. 0 and 10. Okay. So now we're going to substitute all those values into our equation to find our a value, like we did when we did vertex form. So the y value is 10. A value is what we're looking for. X is 0. H is 0.35. And K is 10.6. So 0 subtract 0.35 would be this. At the same time, I might as well take the 10.6 over, so I'll subtract the 10.6 from both sides. Subtract 10.6 from both sides, right? And that's gone, leaving you with 10 subtract 10.6 is negative 0.6. I can square the 0.35 and I get 0.1225. And then the a value, we normally put that at the end, right? We usually have the numeric coefficient and the literal coefficient, right? And we divide both sides. We take that step now and we divide both sides by the coefficient. Divide those by 0.1225. You do the one side, you do the other, divide it by 0.1225. Alright. The 0.1225 divides with the 0.1225. And again, you don't have to show me this. And we're left with A equals. And I like to put A on this side, right? I can just swap the sides. I get rid of all that. And I just take the two numbers and divide them. And I get 4 negative 4.897. So any of you taking physics, you're seeing this number at the beginning of a lot of your quadratics, and I'll let your physics teacher tell you why. Okay? And that's approximately 4.9. I'll use the exact value in my equation that I put in my graphing calculator, but again, that's fine. So we take our original equation, right, and we put A in, negative 4.9. We put H in again, 0.35, and we put our K in at 10.6. And that is your function for the graph of that quadratic. All right, so we'll go to our graphing technology. So put that in our graphing technology. Again, I'm going to fix the window on that. So I only have to go over my x-axis. It's not even any further than 5, so 5, there it is. I don't need any negative. I'm going to show the negative a little bit. I'll show negative 2. All right, and our y-axis, again, we don't need any negative. I'll have negative 5 just so you can see it. And there's a nice picture of our graph. So we got the 0.10, we got the 0.35 and 10.6, and this is what we're looking for here, the time to get into the water. Okay, so we'll just take a picture of that graph. There it is. Put it with our notes. Okay. There it is. Nice, beautiful graph. Okay. And again, I'm going to show you how to do that on the graphing technology as well. Remember, when you turn your graphing calculator on, I always use second function plus 712. That'll clear and bring you back to a nice window of negative 10 to positive 10. So we'll graph our equation. We hit y equals. We put it in negative 4.9. Oh, sorry, it's the wrong button there. 4.9 bracket x minus 0.35, close my bracket, squared, plus 10.6. We hit graph. There's our graph. So we want to change the window around a little bit. Like I said, well, we only got to go back as far as negative 2. No further more than 3 for the x-axis. The y-axis got a little bit above 10. We knew that anyway. Nothing for the negative. So I'll just adjust my window. And you can play with this. Like I said, you're not going to hurt it. Negative 2. I'll go 3 here. We'll go with 1 for the scale. Right here, I'd like to show a little bit, so I'll go negative 1. I'll delete the 0, and I'll go up as far as 12, because I know it was a little bit higher than that, 10.6. I graph it, and I have this nice graph. Okay? So we already knew the vertex. We already knew the y-intercept, but we want to get this value here. All you do is get the 0. Second function, calc. Option number 2 is 0, so hit 2, or go down to 0, hit enter. And you're going to go right until you get to close to the x-axis, and then hit enter, go down, which is going to the right. It looks like it's going down, but go to the right, hit enter for a third and final time, and you get 1.821, which we have in our Desmos program. Okay? There's a little bit different because no, that'd be the same. Sorry. No, that's good. That's exactly what we need. Okay? So, to answer the question, we say the zeros of the function are, and there's two of them actually. There's one over here. I didn't really talk about that, but that's the negative time. But if you do click to Desmos, there is a negative. We don't really talk about it because there's no need. This is what's called an inadmissible value. All right, so maybe I'll grab that for our diagram. Okay. Right, so there's our nice diagram. So there was a negative value. I did skip over that. So the zeros of the function are, it does count. I mean, it is a value, but it's negative time, right? We got to remember that's time. So when we have that, that's what's called inadmissible. All right. Oh, show that in there. Sorry about that, folks. All right, so we have negative 1.121. So we're not calling x, we're just calling 0, so we just less than 1.821. So the solution is negative 1. Again, remember it's in seconds. Is what's called inadmissible because you can't have negative time. Okay? So to answer the question, the divers reached the water after about 1.82 seconds. So that means they were in the air for 8.32 seconds. All right? So that's it for this example. In the next video, we'll finish up the chapter by looking at example number 4. All right? So I hope everybody's enjoying the videos. Thanks for watching, and we'll talk again soon.